Well, hello, welcome back to the Automation Challenge, the Kubernetes operators versus Helm charts. Thank you for joining my talk. First of all, let me introduce myself. I am Anna, happy to be here today with you. I currently work as a developer advocate for Red Hat. And earlier this year, became a Java champion and certified myself as an architect. But moreover, why are we having this talk today is because I have to admit it, I'm a bit of a control enthusiast. And I'm passionate about learning about Kubernetes and automating things. And moreover this, the thing is that when we're working with Kubernetes, we have to really know how to go forward when we're getting a distributed system a little bit more complex than the hello world. And that's what we're going to do today. We're going to look into a little bit more complex than just one microservice situation so that we know how to deal and how to choose what is advantageous for us in terms of automating our work or deploying our work on top of Kubernetes. So first of all, why Kubernetes? Because nowadays, most of the time, microservices are associated with Kubernetes. If you would ask any person probably what they would use for their next distributed system that they're planning to build, they probably would say, well, we're going to make microservices with some programming language, one that we're feeling more comfortable with, probably. And then we're going to use Docker files to containerize, and of course, put everything and orchestrate it with Kubernetes. Because Kubernetes gives us that deployment independently thing, like failure isolation. It gives us zero downtime, a lot of great stuff. Even if you like looking to the Kubernetes.io, in the Kubernetes features, you see a lot of features that do things for you. You see self-healing, you see batch execution, you see automated rollouts and rollbacks. You can even think that it even cooks for you, right? You don't seem to be having to do a lot. It works for you, and that is very much true. However, the story starts simple. It starts with the story of a microservice, because you start small, right? We should start small when we're building complex stuff. We start with the application code. We add to it a Docker file, of course. We need to put it in a container. And then we need to put it somewhere to that Docker file to run besides our computer so that others can use what we're doing, right? And we need to describe that deployment, that application, with some objects in YAML format, typically. And we write one YAML. It can be a very long YAML sometimes because, well, our applications, even if they're microservices, they do need some configurations, sometimes coming from exterior of our application, because we don't want to hard code things in our app. We don't want to go back to those times. We want to let the environment do the magic for us. And then maybe we'd code two YAMLs and separate things a little bit more. And remember, this is just the story of one microservice. Then you start one microservice deployed in one namespace, one Kubernetes namespace. And you're starting to wonder, okay, so now it's deployed in dev namespace. What if I'm needing it to put in another one, two namespaces? I need to write some more YAMLs. And then some more YAMLs if I like to replicate this. And why I need to write more YAMLs? Because let's just say that the environments have different specifications. They are tailored a little bit differently in terms of resources. And sometimes we're having places where just our testing integrated, and we apply many, maybe we do some load tests, and we want to isolate those things. So we start to complicate what we're doing, and it gets a little bit more complex. And then we're thinking, okay, I've did this for one microservice. How about for the rest? It becomes a little bit challenging, right? Luckily, there's a way how to manage this complexity, and not just for one, but for many, with Helm, the Kubernetes package manager. What Helm is bringing is bringing a way for you to create templates for your deployments and separate those templates from the actual values that you're using. I'm going to demo that for you in a second. With Helm and its templates, you can manage and update the Kubernetes configuration. So you still have Kubernetes configurations, but you have an easier way to manage that, and you have like a whole view of what's going on there. And speaking about whole view of what's going on there, Helm is giving you the notion of release. So you see those many configs that you're doing as a single application with the concept of Helm release. Moreover, you can parameterize for multiple environment support. So basically, you're coding the templates, but when you need like to move to different environments or to different namespaces, you're just making another values. So you're separating things. And those being said, let's see some action. I guess it's a little bit, okay, didn't change. It's supposed to change. 1 sec. Let me exit. Yeah, it's better. No worries. Fixed it. So we're going to deploy a few things. First of all, we're going to deploy some microservices. And I have 2 Quarkus microservices in a front end. We're going to build a ticket store today in this session. The first microservice that I want to deploy is the event microservice. And the event microservice is pretty simple, is just offering me some information about the events where I can buy tickets from. Yeah, so nothing fancy, just some very simple logic in here, right? I want to be able to deploy this one, but probably many of you have a way to store your information, right? You have probably a database where you would store these events. So what I'll do, well, I need first to make the installation of my database. I'm going to share the code, no worries. And in the README part, I have the way how to install, of course, the database with Helm. And this is pretty much standard way of installing a Helm chart. Let me make this bigger. Is big enough? Yeah. So this is going to create for me the instance of a database with my own setup and doing things for me with just one command. Moreover, if I'm going to say Helm status event, I can get how well this thing worked. Yeah, it's kind of a lot of information, but you see the revision of my release for this database is 1 and is currently deployed, which is great. Now let's actually work for our microservice and describe it with some Helm charts, right? So let me go to event chart folder. Make sure it's empty. Yeah, it's empty. Clear. And make some Helm charts. The easiest way to create Helm charts is by using Helm create, for example. And I can say Helm create event. But another nice way to subtract the things with Helm is using starters. So for example, you've created some nice templates. But while you're working with your microservices, you realize that those templates kind of replicate themselves. Well, you can use templates with -p and create that chart from your own template. So it's template to template. Now let's look at what got created. And we see a lot of auto-defined things. So even with Helm create, you would get the same files. But in this case, my starter has a little bit more tailoring and a little bit more extras to it, because I like to validate my values just in case maybe I'm not using the right values for my deployment with a schema.json. So this is why I'm using the starter. Now, let's look a little bit into the starter that is here, and let's add a few things to it. First of all, I have the image, the tag for my image, so I have all the values separated here from my actual templates that never are looking into and caring about static values. Okay, you sometimes see some static values, but it's not as many as you would have normally done in Kubernetes deployment, for example. And you also see here some checks that okay, if something isn't defined or not, you can also check this within your templates, which is really great. Okay, so those being said, I think I need to configure my database and use it here. And now that I'm done with this, I think I can Helm install. So just simply install. And I'm going to say this is a simple install for me. And I'm going to install from event. OK. And say Helm status simple. And, well, it's deployed. Just to make sure that things are all good. Let's say kubectl get deployments. And everything seems to be fine. So we have one microservice deployed, and seems great. Moreover, Helm is really nice, because you can do like all-in-one kind of deployment. And we're going to see this for the other microservice, the landmark one. So we can also buy tickets for landmarks with my app. So let me go to landmark leader. Now, this kind of approach of deploying with Helm, it means that you're specifying the database as a dependency, and you can specify that as a global dependency, and you can reuse it with other subcharts there. And afterwards, after you're specifying that one, you can just have it like all in one and manage this as a whole. This is a great approach, like if you don't want to like manage things separately. So in my leader, you see here I have the folder charts. Hope you can see it. And in my folder charts, this is where I'm going to have all the charts that I want to deploy. No more templates in this kind of approach, because I don't need them. Like what I need to define at global level will be found here. So what is going to be available for all my charts will be in the values.yaml. And what I also need to do is like the dependency part is going to be in the chart.yaml. So here I can say, okay, the description, what's the name of my overall deployment, and so on. But I can also specify the dependency. So let me specify the dependency here. My dependency is going to be a PostgreSQL database, of course. My values, well, I need to like give it some details for it, for landmark, and need to format it a bit. Sorry. And, well, of course, after defining this, we also need to define our microservice. By the way, do not worry how to like make a leader from scratch. You find it in the repo. Let me go to charts and make the landmark. So I'm going to say Helm create landmark, also from a starter, because I like starters. Landmark, tree landmark. So now I see that I have a more for this landmark. I also have defined for this one an HPA policy to horizontally pod auto scale. I just wanted like to play a little bit with it. Again, my own values.schema.json. And if I'm looking in my charts and see everything next to it, I'm like looking, maybe I need to do some changes here and to make things a little bit changed. So, because I defined the database at the global level in my big values at the outer level, I don't need this anymore. Maybe I can keep the secret key from where I'm getting the password. But I don't need to specify that at the level of my chart, of my inner chart, the details, because those are going to be nicely propagated from the global part. And this is a nice way, like with Helm, you can also define global values, like available for everybody, and then have tailored for each of the microservice that you're having, like things that are specific to that, and you know that they change only for that microservice. So separation of concerns is really good. Yeah, I think it should be fine with this. Helm chart. Okay, let me install it. Helm install leader from leader. Ah, I have a small mistake. So that's another nice thing about Helm. What it says here is that in my hpa.yaml, which is here, and let me make this bigger, it says that if I have defined the values.autoscaling.enabled, this will be done there. So what I have gotten here is defining this in my values.yaml. And let me go in the charts values.yaml and just simply code it. Auto scaling enabled. I'm going to disable it for the moment. Now it should be fine now. Now it worked. Everything is deployed. Let's just quickly get the deployments. It's slowly starting because it's doing 2-in-1. So it's also like, okay, spinning up the database and afterwards looking over. Yeah, now it's ready with everything. Now, another useful command is like to list all your VMs installments with Helm. You just use Helm list, and you can see everything that you have installed so far, which is great. We have installed like in 2 ways these applications. So now let's look a little bit to some advantages with Helm. And those being, you could see that you can easily prototype an application installation. Helm Create is doing that prototyping for you, and if you're using starters, you can prototype even more. Then you can separate your concerns. Well, your non-final values are in the values.yaml files, and they're separate from the actual objects. You can deploy all those configurations, like HPA, like deployment, services, secrets, config maps, and so on, through a single chart instance. So when you're doing Helm install, you're installing everything. And that is seen like a single release or single revision. Next, you can check the nested values at every level. Like in the case of my HPA, if I have not defined that one, then there was an error there was something guarding me against doing mistakes, right? So it was saying, okay, you didn't define this. You can use ifs, you can use nested control for the things you have or have not defined in your values.yaml. You can also have default values. By the way, use default values when possible, it's good. More distinctive Helm aspects is that you can automatically roll deployments via annotations. Why is this useful? For example, if a config map value is changing, typically in a deployment with Kubernetes, that is not going to automatically detect it for you. Like it's not going to do another deployment because some connection, some configuration changed there. It will probably just say like that. And your application is going to use the old values of, I don't know, of configuration, of like old URLs or whatever. You can use roll me, or you can use another annotation that is checking if a config map has changed in order to automatically roll your deployments and to make sure that things are getting rolled out when things are changing within your configurations. Now, reusability is really much encouraged via include TPL and, of course, _helpers.tpl, where you can define your own templates, like to reuse in all the templates there. And moreover, if you automatically roll deployments via annotations, maybe sometimes you just realize that, hey, but I should keep some resources because they don't change across the deployments. We don't need like to also go with that. We can keep them stable, like in case of the service. So for example, if I would do Helm uninstall to my charts, this service here that has the annotation to keep the resource policy, well, it will stay there upon me issuing uninstall. The rest of the resources will be gone, but I can keep it. I don't know, maybe I can use it in the future. But what happens at the maturity of a system? If we're looking at our system, we have now 2 microservices deployed with each of its database, which is nice and great. However, if we're like thinking in the future and scaling this from 2 to 5 to 10, we're kind of seeing that it's a little burdensome to like manage our own stuff and the database, because, well, databases need to be upgraded as well. You need to maintain them as well. So what do? You're using Helm to like maintain stateful sets objects because that's actually part of that database that I deployed there. That's a little bit difficult to be done with just Helm. So this is why using operators is better, because they not only package human operational knowledge, they also give you a way to maintain better objects that are not as easy to maintain with just Helm. Clients like kubectl or like the dashboard that you're seeing in Minikube or anything that's on top of the basic dashboard that Kubernetes has, they automatically work with operators. They recognize operators. So you don't need like a separate installation of something so that you can use your operators. The resources that you're creating as an operator or the operators are secured and they use HTTPS. So when you're creating an operator, you're also getting the security part. Of course, it's a default, it's a bootstrap default. You need to tailor a little bit around it, but you get a good template on how you should like expand. Next, your operators can be used to create backups or for configuring your clusters. For those of you that have tried to like back up a cluster the hard way, and there are some ways to do that, and some exams have that, by the way. It's not easy. Backing up etcd and all the other actions are difficult to, let's say, remember, do. You're kind of trembling most of the time with everything. And if you have like a cluster of etcds, because yeah, when you need to be highly available and you need to like prepare for the worst, then it's becoming really, really dangerous operation to do this by hand. This is why operators are really handy. You can create backups, you configure your clusters, and you can like let that and trust that to do the hard work for you. So what's next for our system with the operators? Well, first of all, a good place to discover operators is operatorhub.io. You can decide which operator you want to install. Sometimes you have multiple offerings on the same operators. I decided on one, by the way. Follow the deployment instruction. They're pretty easy. They're there in the operatorhub.io. And I kept my Helm charts for installing the application. So I want to solve the maintenance of my database with operators, but I want to keep my app, because my app is actually stateless, is keeping its state within the database. I don't need to like concern myself and make operators yet for my apps as well. And then I can maintain the PostgreSQL database via the operator, because it's way easier to upgrade via operator than just using upgrades with Helm. And those being said, let me escape again. Let's make a switch in the code and upgrade with the operator for the event, because that one is uncoupled. So let me go to event. And I already have my operator deployed, but I just need to change this guy here and use the posse and replace this one. So it's pretty much the same thing. My Helm chart is going to believe that's another place where I'm getting some values, not much. So, to do the changes, let me save this one. Helm upgrade simple from chart event. And this is going to upgrade it. Now let's look at the revision. This one says, OK, deployed. The revision is now 2. And you can roll back really nicely between the revisions. Let me list. Everything seems to be fine. And let's just get the deployments. Everything's fine. So my app didn't feel the change. I will feel the change because it would be easier for me to upgrade the database in the future or make any other maintenance operations with it. How about creating an operator? Well, there are multiple options to create your own operator. Is great. And we're going to use one. We're going to use Operator Framework to do that. So this is the final view of our system. We're going to deploy the last part of our system, the ticket store service, with an nice UI. Well, in the acceptance of a mostly backend developer. OK. So we're going to deploy this one and connect the dots with everything. So let's look about how we get from Helm charts to operators, because I love Helm. I'll be honest on that one. And I did a Helm chart also for my front end. What can I say? Because it's easier. I like templates. So what I did, I published my Helm charts to a repo. In order to do that, I used the GitHub repo as a Helm repository, because I needed a place to do that. And I needed for me to share those with you, to share my charts with you, and I used GitHub. It would have been nice to be just on my local, you know. I checked out the GitHub pages, so I used GitHub pages to publish my charts, package my charts, Then I generate an index file based on the docs directory. That's where I moved my charts. And then the rest is history, you know, git, add, commit, push stuff. So that's pretty easy. You can do that as well. Now, to create an operator from Helm charts is easier too. Next step is like you reference the GitHub repo. You can try this on your own as well. And I give it the name like store because it meant it seemed okay with me. Then I did operator SDK init. So using the plugin Helm with operator SDK, I generated the operator and the API of my operator that Kubernetes is going to look into based on that Helm charts. You can also do this operator creation with 2 operator SDK commands as well, and some copy pasting. But this is the all-in-one command. Not safer, but the easiest one. And afterwards, you can just install your operator and just apply a sample, because thanks to this operator SDK in it, you also get a sample to install. And going back here, clear, cd ticket store operator. So this is my operator here with a lot of resources if I'm going to do this. They're all generated, so I rely a lot on what was generated. But to install it, I can say make install run. And this is starting and installing the operator in my cluster. Oh, come on. Sometimes it doesn't want to cooperate with me from the first, but I'm going to tame it. So let's say ticket store operator, and now let's just apply my CRD. Just to give a look at the CRD that I have. So this is, by the way, auto-generated. I haven't changed much. It used what I had in my Helm charts. So it took the API's definitions from my Helm charts and put them there. So what I'm going to do, like use the regular kubectl apply -f. It's going to be config, samples, charts, okay? And now it's created. This is a custom resource definition, by the way, kubectl get deployments. Okay, things seem to be okay. Clear a minikube IP. This is my IP. And let's get the service definition, kubectl get svc deployed on 31131. Hope I remember this one. Okay, 31131. Okay, so I got my ticket store part. It should work. Okay. I can order, and that's it. It's not the smartest thing ever, and you can see the colors that were picked. I like blue and green. And yeah, it's just a very, very, very small UI, and you can see also the other events, small filtering. I think I have some. Yeah, you can filter by events or filter by landmarks. Yeah, you can also get some ratings. Like if you want to see some ratings, that's it with the UI. That's the joy of it. But what I want to share with you regarding the operators is that you can do this with operators. Get deployments. I'm going to delete this one. I'm going to delete this deployment. It can happen. Maybe there's some colleague that's upset and wants to delete a deployment. Who knows? Oh, not okay. Delete deployment. Okay, this one got deleted. Now, if I'm going to get the deployments again, okay, you could see that this one was started 4 seconds ago again. It was that instantaneous. Operators have this ability to watch over your resources and make sure that they maintain the state of your application, of what you deployed, of everything that you deployed and configured for your app. So make sure that that's available there. This is how powerful they are, and this is a great thing regarding it, because if you like by mistake you delete something, that will be checked. If I would do that only for a Helm chart, my Helm charts would not automatically start a new instance for that to maintain it there, because a simple deployment doesn't have that ability to reheal itself just by that. Operators can do that. Those being said, some takeaways. Well, as you see, you have packaging, custom packaging format with Helm. You can deploy stateless applications, and I would recommend to deploy stateless applications with Helm. And for the stateful sets, and when you need to maintain state, to use operators and to make sure that you're creating maybe your own operator if you need it. Most of the time, operators are being used by software vendors, and you're using that from established software vendors because they're verified and you are kind of trusting what you're installing. Same with the Helm charts. You can also see what charts are from established vendors and see what is safe to use. It's nice that Helm has annotations that can trigger automatic deployments, but also operators bring on top of that, and you can use operators with Helm to automate even more and make sure that you're maintaining the state of everything that you're configuring for your microservice in a good shape. And it's useful most of the time to use operators for, as I mentioned, backups and cluster configurations. Thank you very much. This is where you find the code. I'll share the slides, no worries. And if you are interested in some more resources about learning about operators, about Kubernetes, I can recommend you 2 books that are available for download from these URLs. So Kubernetes Patterns, my favorite. It contains a very good comparison between what is in Kubernetes and patterns that were used as developers to better understand how Kubernetes works and how the Kubernetes resources work. I've been recommending this for a long time to my colleagues, to start understanding better how Kubernetes works. And Kubernetes operators, of course, more on the goodness of operators. And yeah, those being said, thank you very much for listening to me. And I'm welcoming now questions.